going to introduce today and really continue on with our study of quadratics and quadratic inequalities. And the first question will look somewhat familiar. It says the height of the main support cable on a suspension bridge is defined by the function h of x equals 0.04x squared minus 3.5x plus 100, where x is the horizontal distance from the left end of the bridge, and h of x is the height of the cable along the bridge surface. So here's another example of where you might see quadratics in your life outside of school. And the first question says, where is the bridge cable height less than 40 feet? Well, if we take a closer look at our picture here, what we can do is we can mark on our drawing here 40 feet. And what we're looking at is we're looking at less. We want to know where is the graph less than 40 feet. So in other words, what we're looking at is where is the graph underneath this blue line. So when we start here, it says show the setup of the inequality. I would like to say to you that I highly recommend that you write the letter on the left. What do I mean by that? 0.04 x squared has a variable in it. It's a letter. Minus 3.5x plus 100. Put the equation on the left, and I like to use the alliteration, letter on the left, is less than 40 feet. This symbol pointing towards the 100 in this equation is the less than symbol. And there's our setup of the inequality. But the next part says, what's the estimated solution from the graph on the right? Well, where we're in particularly looking at is we're looking at that point there and this point here. We want to know what's the estimated solution. So in other words, what's the x value of the first green points that I just drew in as an estimation? Kind of that green point to the left. Jordan? Let's say 22. So from 22 to, how about an estimation of our green point that's farther to the right? Really? 62. Remember, we're just estimating. I do want to write it in more mathematical terminology here. So I like to do it with the from 22 to 62, but realistically what we're going to be writing is that x is going to be somewhere between 22 and 62. In here, on our graph, is where we're underneath. So, what we're going to do now in a moment is we're going to graph this on our calculator. And when we graph it on our calculator, the first thing that we're going to be graphing is we're going to be graphing the 0.04x squared minus the 3.5x plus 100. But we're also going to graph our green line, which is y equals 40. The horizontal line, y equals 40. And once again, what we need to be familiar with is, what does our window need to look like to be able to graph this? So if we look back at our picture, what we see in our graph here is that our smallest x value looks like it's going to be about 0. And our biggest x value on this graph is 100. And when we look at the scale of it, 0, 20, 40, 60, 80, 100, we're going in increments of 20. Those are the x-axis values. Well, if we glance at the y values on our y-axis here, again, we still start with 0. The highest y value that we see in our picture is 100. And just like the x-axis, 0, 20, 40, 60, 80, 100, our scale is 20 in this particular picture. So we're going to pull out our calculator, which is here, and we'll start with typing in, and let me go, I don't know if it's back there, but if we start by going to y equals, and we're going to type in that equation, which I have in from earlier today, but y equals 0.04x squared minus 3.5x plus 100. And we're also going to type in, for our second y value, we're going to type in the 40. But if you type that on your calculator, you're probably not going to see much of anything until we go to the window. And again, I'm fortunate enough that I have the parameters in here from earlier today, but we went to the window button, and our x minimum value is 0, the smallest value on our graph. And the x maximum value, the biggest value that we can see on our graph, is 100. And we went in a scale of 20. And we're going to have the same things for the y. Y min is 0. Y max is 100. Our scale is 20. And once we've got that, then we're going to draw the picture. So now if you've got that in, we can type in graph. And we get that. So we already have that drawn on our paper, so that looks really familiar to us. So as we look down on our page here, it says solution from the graph. Solution from the graph on the calculator to the nearest tenth in symbolic form. Note, in order to find the solutions, we must find the intersection of the two functions. So in other words, what we're trying to do is we're trying to figure out what's the value, the x value of the green point, of each of the green points, in fact. What's the x value? So we're going to use the intersect button, and if you're not super functional with your calculator, the button we're going to use is second trace. You might make a note of that if you need to. Second trace, and then there's going to be an option to say intersect. So we go back to our calculator. Second trace gets us up to the calculate part of the screen. Here at number 5 is intersect. And what we're going to get is we're going to get some sort of flashing value there. And I'm going to go a little bit here to the right on our first curve. Try to get close to the red line. And I'm pretty close. You don't have to be quite so close. Like usual, these numbers on my calculator do not need to be the same on yours. But we're going to press enter. That flashing cursor then jumps to the second curve. I don't move it. I leave it there. You can move it if you want to, but it's pretty close already. So we're going to hit enter again. And then thirdly, we've got the guess. We're going to hit enter one more time. And that's going to give us our intersection here of the 64.09. And as I try to scan it in here for video purposes, I cannot scan it in. I'm going to have to delete it. But we end up with here on the right side, we've got 64.1. But we also need to figure out, well, what is the left side value? So we're going to go back to our calculator, and we're going to do second trace and intersect again. Second trace, number 5, intersect. And this is what takes me a long time up here at the board. So it'll be faster for you, but scrolling all the way over to where we're close, to where they intersect kind of on the left-hand part of our graph, It just takes forever, and I probably hit it too many times now, and it's really going to get funky in a minute. Oh, good. But I lucked out today. Some were close. As we've gotten close now, we're going to hit enter. It jumps to the second curve, which is our red line. I'm not going to move it at all, hit enter. And then thirdly, we guess, and there we get our intersection of 23.4. So what we have is 23.4 and 64.1. We want to write it in symbolic form, which means that our answer, our x value, is going to be somewhere between 23.4 and 64.1. Now, just a real quick note, let's look at what our estimates were. We picked between 22 and 62. Are we reasonable in our answer? Definitely. Definitely. Now, as I go back and look at the picture here, because we do want to draw this number line, what we're looking at in this graph here, it says less than. We want this part of the graph that's less than. And really what we're doing when we answer these questions is, where is it less than? And the where is going to be the x value of the graph, which really looks like a smiley face there. So when we draw our picture down here, it's going to be similar to what I just drew in the picture. 23.4 is somewhere in here, but remember, there is no equals in that inequality, so we're going to have an open circle. So somewhere there, we could scoot it over a teeny bit, maybe. Somewhere there. And 64.1, again, open circle, because there's no equal. Nothing underneath, nothing in the middle. But when we're representing our answer here on the number line, we want all of the values that are in between there. And that tells us where our graph is less than 40. As we look farther down on the paper now, to part B, going to be looking at this similarly. Same picture, different situation now. Where is the bridge cable height at least 60 feet? Well, let's draw in our line at 60 feet. And I wish I would have made that a blue line, but oh well. There's what we're looking for is, where is it at least 60 feet? When we come up over here to show the setup of the problem, then remember the letter on the left, still the same value, 0.04x squared minus 3.5x plus 100. And now, at least, I'm going to circle that. At least means that it's going to be greater than or equal to 60. So what some of you might need to do, because you struggle with this symbolism sometimes, is draw an arrow. At least means greater than or equal to 60. But I also do want to say, letter on the left. If you can put all your variables on the left, I think that these work out a little bit better. So now we have a picture. We want the estimated solution, so we're familiar with what we're doing now, which is going to be roughly those two blue values, the x value of those blue points. When we look farthest to the left, what do you think a good estimate for the left blue point is for the x value? Matthew? 14. Pretty random. I would have gone something like 15, but that's That's the beauty. You get to pick, and there's no wrong answer. What do we think that the right blue point is, roughly? Jordan? 75. So, somewhere around here. But do we want values that are going to be underneath this green line, or do we want values that are going to be above this green line? We actually want above. It needs to be at least. And what I've seen some other teachers do is I've seen them highlight above. I don't know if that's helpful or not, but I want to throw that out there. Because now what we really want to do is we want to figure out, well, what are those values? And then we're going to put them back into a format that we can use here. So we're going to go back to our calculator. We don't have to change too much. We already have that first equation in. We just have to change this one. And once again, this one says at least 60. So change that 40 to a 60. We still have the same picture, so we still have the same window. But there's our picture this time. But now what we want to do, we want to figure out what are the intersection points. So we're going to solution from the graph on the calculator to the nearest tenth. Second, trace. And then we're going to go to intersect. And close enough. Enter. It jumps to the second curve. I don't move it at all. Enter. And then when we guess, we get our value. 73.98, which when we round it to the nearest tenth, what does it become? 74. Definitely reasonable. So instead of 75, it's 74. All right, Bradley, talk me through it real quick. Second and what? Second, intersect. And then what? Maybe a little bit quicker. Not much, but better. Tell me in a couple minutes. So apparently there's a couple ways to do these on the calculator. That is brand new to me, and I thank you. Any tricks you can give me, I need them. Trust me. But when we hit enter there, we're going to jump to the second curve, enter. And now when we guess, we end up with 13.5. So Matthew, you were remarkably close. So 13.5 is our other value here. When we round to the nearest tenth, and I wasn't looking too close to make sure, 13.51, so I am good on that. But when we write this in symbolic form, what we need here is we need values that are above that line. So all of the x's in this case are going to be x's less than or equal to 13.5. And then it's going to be, or, I'm going to put that 74 over here, x is greater than or equal to 74. Because we're in one part of the graph, or we're in another part of the graph. So when we look at our picture here, 13.5. Well, somewhere here, notice that I did fill it in. There's an equals in this inequality. But we're going to go that direction. And then for 74, filled in circle, and we're going the other direction. It's in two different parts of the graph, unlike the first one where it was all contained in between. But as you finish up on that problem, I want to flip over to the back on part C. I know that I'm not going to get done with everything, but I want to talk about the interval notation here on this problem. And first of all, it says solve x squared minus x minus 6 less than or equal to 0. Well, in order to solve, what we have to do is we have to factor. So without spending a lot of time on the factoring, x squared minus x minus 6 factors to be x and negative 3 and positive 2. That's our factors. And I know, I'm going fast here. And then we would take x minus 3 equals 0 and x plus 2 equals 0, and we'd add 3 to both sides. So we get x equals 3, and we get x equals negative 2. And had we had a little bit more time, we would have done that earlier in the problem. When we write this in symbolic notation, make sure that you put the smallest value first. And negative 2 is smaller than 3. And that's why I wrote that first. Once again, on this particular problem, there's an equals in there. So when we graph this, negative 2 is here, 3 is there, and x is all the values in between there. So just like our first example on the front. But like I say, what I'm looking here is what's the interval notation? Well, in interval notation, it's going to be negative 2 to 3. But because there's an equals in this problem, equals means that we put a bracket in there instead of a parentheses. Now in part D, it's the same thing, same kind of thing. X squared minus x minus 6 is greater than 0. And I know we haven't dealt with how I got the answers here except for the 3 and the negative 2. But it's still going to be negative 2 here and 3. This time it's the greater than, but we end up with x is less than negative 2 and x is greater than 3. And I know I didn't talk about y, but we're going to continue this on Monday. But stay with me for the interval. Don't put your stuff away for the interval. I still have time here. When you graph this, it's going to look like our second example on the front page did. Like that. In interval notation. And you did see it, but it was a week ago. This is negative infinity to negative 2. Infinity always has a parentheses. And then you have what's called a union. It's a U. That means joined with. And then our other value here is 3 to infinity.